Go. Hi everybody. Tonight we're going to talk about how does the brain become addicted. And this is going to be live streamed on Facebook, so as long as you don't come up here, you probably won't be in the picture. But if you want to leave your voice out, you can, or just raise your hand and not say your name if you want to remain anonymous. It's up to you guys. Okay, so Merry Christmas to everybody. I don't know that I'll see all of you before Christmas. Some of you I will. So I put together information from Nora Volkow. She's the one who discovered the stuff that we're going to talk about tonight in the brain, which is about what happens in the limbic system that creates addiction in the brain. Helen Fisher discovered that when somebody's in love, and you show them a picture, the very same thing, a picture of their loved one, very same thing happens in the brain that happens with all the other addictions. So love addiction is a real addiction, just like every other one. And she's also she's the advisor for Match.com. So don't go on Match if you don't want to get your perfect match. The U.S. Department of Health and Services, a couple of articles, information I pulled from that, and somebody Rakic, information from him about the evolution of the neocortex. We'll talk about that. And then the rest of the parts of the brain that we're going to talk about come from Bruno Dubuc. So our objectives today are understand what happens in the brain when the brain becomes addicted to a substance or a behavior, and understanding why the addict loses executive function, which is the prefrontal cortex. Why does that go offline once the addiction has changed the brain? We're going to talk about what acquired narcissism is with relationship to addiction, because that happens as well. And you'll be able to encourage a friend or a client or loved one's healing process from addiction and acquired narcissism. You'll know how to do that. And I'm also going to explain why addiction is not a moral issue and it's not a cop-out. So Nora Volkow has her own, she has the NIDA website. She's the director of NIDA, and this is about her and the bio and all that. And then she's also got a TED Talk about addiction, and in her TED Talk she actually talks about food addiction, which I thought was really interesting. She seems to be more interested in food addiction as opposed to some of the other addictions. So how does our brain operate? Well, first we have to look at all of the evolutionary parts of the brain. They talk to each other, but some of them don't talk to each other very well at times. So the reptilian brain is the oldest part of the brain. It is 500 million years old. That's the part of the brain that sits right here at the base of the brain, and it's responsible for life support like respiration, blood pressure, heart rate, reflexes, and our startle response. It's the oldest part of the brain. And if you took like fish and mammals and birds and apes and put them all together, you would come up with our brain if you were able to put that together correctly. So what's in the limbic system? Well, this is where addiction lies, and that's what we're going to be talking about most tonight, the limbic system. So it's in what we call the midbrain. It's in this area, and in that area a number of things occur. It's where addiction occurs. It's where motivation is or isn't, if they're not the right chemistry there. It's where we form all of our memories. And we also get what's called implicit learning. Those are the things that what you're experiencing tonight is explicit learning. I'm giving you information, you're taking that information in and beginning to integrate it. Implicit learning is how you learn the sound of your mother's voice. And that occurs within the first few hours of birth. So anything that you learn without somebody teaching you something, that's called implicit learning. For example, if your parents said, you should do this, and then your parents did that, what do you learn from that?
Do what they do.
Right, and so that's implicit learning. Not what they said, but what they're modeling. So implicit learning comes in the limbic system along with formation of memories, behavior, or whatever it is that we decide to do. And the sense of smell is there too. parents, little babies, when they smell their parents, will remember that for the rest of their life, as well as the parent's voice, what it sounds like. So, and this one is 200,000 years old. This is the part of the brain that's the newest. It's the youngest part of the brain, and it's where we have executive functioning. Now, the prefrontal cortex for us is different than the prefrontal cortex for lesser apes. And so that's the place where we do executive function. This is the part of the brain that's not working very well when we're in addiction, because the limbic system is overriding what should be happening in the prefrontal cortex. So let's see what we do there. So it's the override of the more primitive parts of the brain, the midbrain and the reptilian brain, or limbic, and it's where we have explicit learning. It is where we integrate and interpret information that comes in from the outside, what we hear, see, smell, taste, or feel on our skin. And it's also where a lot of stored memories are interpreted. So how the brain develops. So first, in the womb, when we're still in utero, the reptilian brain first, then the midbrain where the limbic system is, and then the neocortex, and then the prefrontal cortex. At birth, the only thing that's in place and functioning at full capacity is the reptilian brain, unless you've got a preterm baby. A lot of times preterm babies have to be on life support because their body is not doing what it should. Oftentimes preterm babies will not regulate their own temperatures. That's why they have to be in little, what do you call those things? Incubators, right. So normally at birth, our reptilian brain is in place and it's doing everything it's supposed to do, unlike the midbrain, the neocortex, the prefrontal cortex. So it begins to change and grow from hours old throughout our life. And thank God we have some neuroplasticities, because if we didn't, none of us as addicts could recover. Our brain would not repair itself. And then the next part of the brain development process is pruning. And it begins just like everything else, starts in the reptilian brain, then midbrain, then neocortex, and then prefrontal cortex. The pruning off of the parts of the brain that we don't need occur from 6 years old to pre-adolescence. By the time you're an adolescent, everything that's going to be pruned off in your brain that's unnecessary is already gone. And then the next thing that happens is myelination. That's where we get insulation on all of our neural pathways and all of our nerves. When we don't have myelination, the signals that run through the neural pathways are much slower. And so that's why little kids can't think as fast as adolescents, and then adolescents can't think as fast as adults. Sonny?
Why prune? It sounds like we have excess brain matter.
Yes. We have 1 quadrillion synapses at birth. By the time we are, come on in, hey Michael, by the time we're adolescents, we have half that many, which is 500 trillion. So we start out with 1 quadrillion synapses, those are little neural pathways, and by the time we're 13 or so, we have lost half of those synapses. Now, here's the interesting thing about that. I'm glad you asked about that. When a child is stimulated for, let's say, hearing, they hear sounds, smell, visual, those parts of the brain fire and they begin to develop. Without appropriate stimulation, kids are going to prune off those needed areas of the brain. If you blindfold certain mammals, after a certain time of development, you take the blindfold off, their eyes are working perfectly, but the neural pathways that go to the rest of the brain to interpret those visual stimuli is not working, and it never will form. There are certain things that only form during a predetermined period of time in our childhood. Now, myelination is just the insulation, and again, it starts in the young or oldest part of the brain, and it works its way up. So adolescents don't think as fast as adults do, and we're not finished myelination in our brain until we're 26 years old. Absolutely. Anytime, ask questions.
When you were talking about the like blindfolding, and then so I got confused when you talked about.
Okay, let me say a little more of that. So if the eyes don't see things, there's no stimulus coming in, then the neural pathways from the eyes to the part of the brain that interprets visual stimuli, it doesn't grow. And the pruning piece, and so he had a really good question about why pruning. Well, it's, all of this tissue that's in the brain is very high fuel. It takes a lot of fuel, a lot of our nutrition to be able to support and continue supporting those parts of the brain, because this is the heaviest fuel consumption in our body. And so if we don't need it, we can use that fuel for other parts of the brain that need it and the rest of the body. So it's a fuel efficiency is what it's about. But unfortunately, for example, in the early 1900s, there were a lot of orphans in Russia, and they did a lot of studies on those orphans because it was an unusual situation. And of those orphans in that orphanage, because they only got fed, clothed, kept warm, had their diaper changed, and it probably wasn't all that regular. Those kids, when they reached the age of 12, 75% of them, 12 months, 75% were dead because their brain wasn't stimulated enough, and so the brain just pruned itself off and died. Those kids died. Any questions about that? So if the parts of the brain that you need are not stimulated within a certain period of your childhood, they can be pruned off. Last part of the brain to develop is the most sophisticated, but it's also the weakest in terms of which message do I listen to in my brain. So the one that I don't have any control over is the reptilian brain, because we don't think about breathing. We don't think about making our heart beat. We don't think about digesting our food. That's all automatic, or what we call involuntary. So the newest part of the brain is this, and that's the part that goes offline when we're in addiction. So that is the most sophisticated, the last to develop, and the weakest part of our brain when it comes to making a decision about what my next behavior is going to be. So the strongest parts, like the reptilian brain, and usually more so the limbic part of the brain, are the ones that override the rest of the sophisticated parts of the brain, and especially when the individual's under a lot of stress. So for example, a lot of pressure with work, illness, a lot of pre-existing trauma or new trauma, anything that's a highly emotional situation, and especially physical pain. When we work with addicts, and when they're having any of those issues, we try to give them a ton of tools to help really keep this part of the brain online, so that the limbic system doesn't say, you're in pain and you deserve to shoot up some heroin, or you're in pain, you deserve to go and eat a whole gallon of ice cream. You're in pain, so you deserve to blah, 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 and go do those things that we're trying not to do. We're trying to change those behaviors, but the limbic system is very powerful. So the limbic system in the midbrain, these are the things that it does that's responsible for those parts of our behavior. Yes?
In terms of those stronger parts of the brain overriding the decision-making part, is that the root of B halts?
Absolutely.
So that's anything that's cortisol mediated.
Absolutely.
Okay.
Absolutely. So that's very good. So that's one of the reasons why we keep that sign on the wall there, and we talk to our clients about don't get too hungry, angry, lonely, or tired, because those are all stressors that can start your limbic system overriding your prefrontal cortex. And so we have to have what I call a lot of insulation between us and picking up the first joint or the first drink or looking at pornography or, flirting with someone or having sex outside our primary relationship. So just a couple of things on this slide. So this is an illustration of the limbic system and a lot of the stuff in it. The primary ones that we're going to talk about that are on this slide are the amygdala and the hippocampus. This is the thing that creates the memories. It's in our limbic system, and it's kind of like the clearinghouse for memories. So they're not necessarily stored in the hippocampus, but when we think, what was the name of that restaurant we went to last Thursday night? You're calling on the hippocampus. And so wherever it's stored in the brain, this starts to search for the memories. And this is one of the first things that goes when we get older. Now, the amygdala is important because it tells you one of two things. Am I safe or not safe? Am I safe or not safe? And the amygdala turns on the sympathetic nervous system. So if the amygdala is on, I'm in sympathetic nervous system stimulation. So a lot of the things that we do to prevent that amygdala from turning on are things like prayer, meditation, going to a meeting, talking to other people, because it helps to keep the amygdala turned off. The things that prevent the amygdala from turning on or start to slow it down are things that create what chemical in the brain?
Cortisol.
So it's the opposite of that one.
Oxytocin.
Oxytocin, that's right. Yeah. So if we are getting a lot of connection from other people, we like the people we hang out with in recovery, we are much more likely to have the amygdala turned off. And so when the amygdala is off, it's in a state of homeostasis. So it's a relax and rejuvenate, a chill out state that we want to be in. So this one's got a lot of information, and so I thought I would take that and simplify it a little bit. So in the limbic system, the parts that we really are targeting are the olfactory bulbs, that is smell, the sense of smell, the hippocampus, memory, amygdala, am I safe or not, the ventral tegmental area, that is the root of where addiction begins, and the nucleus accumbens. And I'll have more pictures of those in a minute. So the limbic system, with these things and other parts of the limbic system, these are the things that it supports. And emotional life is largely housed in the limbic system. That's why it's so important. And that plus it is the place where we form memories and retrieve memories as well. And in that area, we know the amygdala does this. It determines whether or not I feel safe or not. Now, in adolescence, they are most likely thinking and making decisions from the limbic system, and so it's going to be more of how I feel. I feel like doing this, or I feel like doing that. Those are the things that motivate them. Not, the last time I went out and got drunk and passed out, I ended up in jail, so I probably shouldn't do that again. They don't do that. They don't think like that with the prefrontal cortex. I feel like getting drunk, and I don't care that I ended up in jail and passed out and had a wreck and all these other things. So that's what it looks like when the limbic system overrides that prefrontal cortex. So it looks like this. So here's the prefrontal cortex in the brain. This is the nucleus accumbens, and that's the ventral tegmental area. So in the ventral tegmental area, it produces some dopamine, although some dopamine is produced in other places, but it's got a straight line over here to the nucleus accumbens. So if I taste sugar on my tongue, or put tequila in my body, or see a guy that I think, oh man, he is really hot, it fires the ventral tegmental area, it releases dopamine that goes over to the nucleus accumbens, and then the nucleus accumbens sends back a signal with another chemical. It's called endorphins. So what are endorphins? The body's natural opiates, the body's natural painkillers, and it feels good. It feels really good. And so the nucleus accumbens is saying to the VTA, let's do that again. That was great. I want to do it again. And then it gets stored in the hippocampus. So that would be all fine and good, except that it also sends the same signal over here to the prefrontal cortex. When you do that over and over and over and over again, the prefrontal cortex does not care what the consequences are. It's going to do it anyway, whatever it is.
Is this why behaviors are reinforcing, even deleterious ones?
Yes.
They're self-reinforcing.
Right, especially if you get some kind of hit from it. If you get some dopamine, and dopamine's an important chemical in the brain. It's what makes you get up in the morning and go to work. Get up in the morning and go do what you like to do. Get up in the morning and go play golf. Get up in the morning and go drive your boat. Whatever it is that the reward system has stored that is something that you really like to do because it's causing you to release a lot of dopamine. And this piece right here, what you just said, I feel like going to get drunk. That's what addiction is. It's not, the last time I got drunk, I threw up and I got sick and somebody stomped on my head, so I don't want to do that again. It's like, no, I feel like getting drunk and I don't care if I get my head stomped in or I kill somebody or whatever else, because I feel like doing that.
It'll be different this time.
It's going to be different this time. This time I'm not going to pass out. This time I'm not going to get in a wreck. So these areas of the brain, the ventral tegmental area, nucleus accumbens, hippocampus, the prefrontal cortex, and the neocortex, and the amygdala all work together to create what we call the progression of addiction. Yes?
What part of the brain is where my addict voice is coming from?
The limbic system.
Okay,
Yeah,
that's where she resides.
that's where she lives.
Collectively, not in any of these individuals.
Right, right. Yeah.
Well, that'd be the value for cognitive behavioral therapy.
Absolutely. Yeah, and so that's a really good point. So when we get a brand new client in that's in the midst of an addiction, what we want to do is educate, and ask them questions and have them answer and write the questions down. And as that happens, it starts to stimulate this part of the brain to repair itself and come back online. But it takes stimulation, repetition. And it's really interesting to watch. In about 3 months after they first get here and are abstinent and they're doing these exercises, they go back and read the first time that they wrote whatever the exercise is, and they'll go, who the hell wrote that? I don't remember writing that. That's crazy. So dopamine is the driver. It's the thing that motivates us, compels us to act, compels us to go acquire something, whether it's cocaine or somebody we want to have sex with, or a line of whatever, or smoking crack, or going gambling. It doesn't matter what the behavior is, as long as we get some dopamine. It's the thing that makes us do everything that we choose to do. So here's another really good picture of the VTA, and then the nucleus accumbens is in this area, and here's the dopaminergic pathway into the frontal lobe. So a lot of dopamine goes to the frontal part of the brain when we're in active addiction. And I can't say this enough, the limbic system is older and it cannot reliably provide the brain with current, accurate information. So much like the reptilian brain and the amygdala, the limbic system doesn't have a clock. The amygdala is in the limbic system. It does not have a clock. So when I see something that reminds me of an event that occurred to me 30 years ago, it's not like it happened 30 years ago. When it pings on that memory in my limbic system, it's like it's going on right now. And one of the things we do with people who have a lot of trauma and this part of the brain's engaged is we remind them, what's today? You're here. There are no tigers in the room, and whatever their tiger looks like is what we talk about. There are no saber-toothed tigers in the room right now. You're here in this place. It's 2018, December. So it helps them to start getting that prefrontal cortex online so they know, my dad's not about to beat me. This person isn't about to sexually abuse me. I'm here in this room and there's safe people around me. Because these two can't tell the difference between 30 years ago and right now. They don't have a clock. So addiction is about instant safety or relief. I'm trying to relieve what my amygdala tells me is stressful, it's not comfortable, I'm not safe. And so the addiction in that moment is about short-term safety. I'm trying to get safe. I'm trying to get relief for how I'm feeling. Sometimes it's terror, sometimes it's pain, sometimes it's feeling lonely. All of those things, our addict says, I need instant relief. And that's about short-term safety. Now, and the amygdala is about right now safety. So what do I need to do to stop whatever seems to be coming at me so that I can have safety? It's long enough to be able to get to a safe place. And so the addiction is trying to stop the immediate threat that the amygdala tells me is going on right now. Now, the prefrontal cortex is where a clock is. So it is talking about, it processes information that's coming in right now. So what do I see? The visual stimuli. What am I hearing? The different things that I'm hearing. And what do those things mean? So the prefrontal cortex is about current data, long-term survival. So this over here looks unsafe. If I go this way, that's kind of moderately safe, but this is probably the safest path to go in. So I'm going to take this path, whether it's, away from the strip club, or it's away from the liquor store, or it's away from the casino, or whatever it is that these other paths represent. So the limbic system's drive to acquire the substance, do the compulsive behavior, becomes stronger and stronger and stronger as the behavior continues. And so it means that the prefrontal cortex is less capable of overriding this feeling decision that I want to make. Now, eventually, the prefrontal cortex has no ability to override the limbic system. And so that's when we know our disease has progressed a lot. So how does it start? It starts with repetitive highs. And that also has to be where it stops. We have to stop those repetitive highs. So in the prefrontal cortex, in the limbic system, and in particular in the nucleus accumbens, there are nice, fat, juicy dopamine receptors. We call them D2 receptors. These receptors receive that chemical signal of dopamine, and it says, ooh, this feels really good, let's do it again, and then it sends back the endorphin signal. But after you do that again and again and again and again, the healthy dopamine receptors start to die off. There's really good, what we call fMRIs of the brain that show the lack of D2 receptors in the brain after someone has been high again and again and again. It doesn't matter if it's gambling, food, heroin, cocaine, sex, whatever it is. There's a loss of D2 receptors in the brain. And so the healthy dopamine receptors die off, and they either aren't replaced or they're replaced with small and very insensitive dopamine receptors. So the same thing that used to make us really high, we do the very same thing today. It's like, meh.
So you're saying that the implicit learning reinforcement comes from the endorphin release from the nucleus accumbens, right?
Right.
Is that how it always happens? That reinforcement happens external to whatever physical chemical you're ingesting?
Yes.
Okay.
Yes.
So that's always that's released in response to the ingestion of the chemical. It triggers it in some way.
So it's like, you know how we used to say, and I'm going to tell you my age here. We used to say when you put a $20 bill in a cocaine addict's hand, what happens?
They buy cocaine.
No, they get high, and then they buy cocaine. So their brain's already high before the stuff goes in their nose.
Gotcha.
So what happens when you pass the bakery and you really like pastries? Your mouth starts to water. and you start to feel really good and thinking about going into that bakery and getting that gorgeous cake. And so it's incoming data on the tongue, but it's also a visual stimuli. And for some people, when you pour the bourbon in the glass, and you pour the whatever else you're going to pour, and you hear the tinkling of that glass, so that auditory stimuli, you're already high before you've ever put the stuff in your mouth.
Hey, but what are the effects of antidepressants on this whole?
So one thing that the serotonin savers do is that if we come out of childhood and we've had some PTSD and some trauma or not gotten what we needed, we may feel less than, and what that means is we've got less serotonin in our brain. And so there are a few ways that can happen. You could be not producing enough, or you produce it and it's not very effective. Or the third thing is the receptors, like the dopamine receptors, the serotonin receptors, are not effective in responding to the amount of serotonin that's in your in your synapses, in your neural synapses. So if you can raise the level of serotonin, you're much less likely to seek out this dopamine high. When we feel bad coming out of childhood, and a lot of us did, then we're going to figure out what makes me feel better, what gives me relief, what makes me feel safe. And we pick out different types of chemicals based on what we need our brain to do. And we may try 5 or 6 before we find that one, the drug of choice. And it may not be a chemical, it may not be a mood-altering substance, it might be food. Or it might be getting that hit from that dude that's making that eye-to-eye contact with me across the room. My first year of AA, I was getting high, sitting in a room, looking at the guys across the room to see who was looking at me. So I wasn't sober chemically in my brain my whole first year of recovery because I was getting a hit off of people being attracted to me. And so, yes?
A long time ago, a recovering cocaine addict told me that he had heard in rehab he wasn't addicted to the coke, he was addicted to the effect that the coke had on his body. Which, is that compatible with what you just said?
Absolutely.
Well, okay, but see what you were saying, you know, that $20 bill, I was thinking, let's roll it up. But with a $20 bill, that would get somebody high.
Yeah.
But then what happens when you start pushing stuff through the $20 bill?
So if you start snorting using your $20 bill, you get even more high. It's another reinforcement for that. And you get the additional high of the chemical as well. But your brain remembers, this feels good, and just remembering that can release the dopamine exactly the way the cocaine released the dopamine.
Oh,
Yes, ma'am.
so, like, all this time I thought I was, like, addicted to working so I could, like, because of, you know, clothing, because I know I'm always going to be a recovering, you know, sex and love addict, but I just heard you say about the hits, like, you weren't sober your first year chemically. Well, I was, you know, sober from drugs and alcohol 5 years, but up here I was miserable and no one understood why. You have 5 years, get away from me. But that was a long time ago. But I think could it just be money? Because I know I can go get something.
Money is another addiction. There are many different.
But even if I earn it honestly.
Yeah,
Oh
even
my
if you
God,
earn it
that's not
honestly.
fair. That's really, oh God, I didn't know that. Sorry.
So, did I answer your question?
Yes, I'm sorry. I didn't know that though. I feel bad about myself. I thought only if you earned money just in general can, even if you're doing it the right way.
So let's take a look at work addiction, because that's another one. And different behaviors and different chemicals hit different neural pathways in the brain. For example, if you're an adrenaline junkie, you're not going to want to do downers. You're going to want to do methamphetamine or amphetamines. Does that make sense? If you're a food addict, you're probably more likely to use narcotics or downers. Food is numbing. That's a numbing pathway. The other one is the high arousal pathway with amphetamines, cocaine, all of that kind of. It hits a different part of the brain, but it still also produces that feedback loop with the ventral tegmental area, the dopamine, and then the endorphins that come back to the ventral tegmental area. It's still feeding the same place in the brain.
Thank you. I guess I'm just disappointed with the answer.
Sorry about that bad news. So, the progressive nature of the addiction. So these are the things that have to happen for you to become an addict. There has to be repetitive highs, and this affects the dopamine receptors. Then we start to lose dopamine receptors, the D2 receptors, and you get a decreased high with the same amount of stimulation. So a fifth of vodka maybe worked for you at one time. Now you got to have 5/5 of vodka. Or 1 ounce of marijuana used to do it for you, and you have to have a lot more than that to get the same high. And that's one of the criteria that we use to determine if you're an addict or not. Do you feel the less pleasure in the things that used to get you high? That means you've lost D2 receptors in the brain. And we begin to crave more dopamine, and we crave anything that'll help us get more dopamine, including, and here's one that I did. I made up some guy in my head that didn't exist, and every night I'd have a little conversation with him before I went to bed because I was trying to numb out and go to sleep, and that felt like a way for me to soothe myself. But it doesn't work because after a while you have to create a new dude and make it even a bigger high. So we don't have to have a chemical in our body. And I really didn't understand that for a long time until I started studying sex and love addiction and realized how much it involves that area of the brain. And so, I can think about somebody and get high. And so, it's kind of like if you're in AA, you put the plug in the jug, you take that tiger and you lock it in the cage and you throw the key away. You don't ever have to go back in there and pull that tiger back out. But if you're a food addict, you got to go unlock the door and walk that tiger 3 or 4 times a day, and you're like right there with your drug of choice, and then you go put it back in the cage. But with sex and love addiction, there's no freaking cage for the tiger. It's out all the time because it resides in our head and in our memories. So the next part of how the addiction is progressive and you have even more loss of D2 receptors is when the amygdala becomes involved. So as soon as we do something that feels unsafe or we experience a stimuli from outside of us somewhere that turns the amygdala on, it instantly turns on the sympathetic nervous system, or it either turns it on or it turns it off. So we're either in high arousal or we're in a resting state. Now, when the amygdala is on, it stimulates the sympathetic nervous system, and that raises the adrenaline level in our blood, the potency of the dopamine. And this is what the addict's trying to do, right here. The addict, as addicts, we are trying to increase the potency of the dopamine. Well, epinephrine, that's a stimulant. Dopamine, when you put those two together, you have increased potency of the dopamine, the little bit of dopamine that you may have left, and it helps to have a stronger effect on the D2 receptors that are left. So, we may be doing the same behavior that we did before, but if we do it in a very risky way. For example, I had one guy who was a resident, surgical resident at one of the hospitals downtown. He would go to the scariest, wildest, most dangerous part of town and pick up a prostitute. But he didn't do that in the beginning. He would go to some place that was safe or say, hey, somebody I can hook up with. And then in order to increase his high, he started going to the riskiest, scariest parts of town. And he wasn't a drug addict until his sex addiction progressed to the point that he was doing all this risky behavior. And so he would have to use other substances to try to calm himself down afterwards, but keep his high up in before and during the activity. So even though we've lost dopamine receptors, people figure out how to get more high on the same level of dopamine, or they figure out how to do a different or a new or more novel or more frightening thing so that I can increase the potency of my dopamine or try to get more, extract more dopamine out of my ventral tegmental area. So when that happens, we have an impaired assessment of danger. Now, how many of you grew up in a household that sometimes it was dangerous and there was shit flying through the air? Well, when you've had that happen to you, we have an impaired assessment of danger. We don't have a good danger filter, because when that stuff's going on, we become numb to what should look like a lot of danger and feel unsafe. So then not only do we have problems with trying to get our amygdala started, we don't know how dangerous things are that are standing right in front of us because of our impaired danger filter, and we are going to do more and more and more really scary, risky behavior. I put myself in some situations that most people would be shocked about. Didn't know it was dangerous. Yes.
When someone like stops, realizes, comes to realize, wow, like you said, they answer the questions and they finally realize, wow, that's what I was doing. And can they come to a complete black and white with that? Just be not scared of everything, but be extra. Maybe so a lot of people call me too cautious. I'll put it that way. But I'd rather be too cautious than not scared.
I can't trust myself always to have an accurate assessment of the danger that may be right in front of me. So I call somebody and say, here's what I'm thinking, or here's what's going on. What do you think about that? And they'll go, oh my God, Ava. And I'll go, okay, I got it. That's all I need to know. I'm not assessing the danger present accurately.
So, I may not be understanding this correctly, but it sounds like you plotted out a sort of, self-reinforcing, a positive feedback loop of increasing dangerous activity or risky activity.
To try to get more adrenaline going.
Right, then you also put that in the scope of childhood trauma, which I thought normally resulted in PTSD,
Yes.
which I thought was characterized by a strong aversion towards similar events occurring. So how do those two trends reconcile?
So that's a really good question. So let's say that, for example, one of my childhood traumas, I'm afraid of spiders. So you put me in a room with the spider, it would be unwise of you to come between me and the door, because I'm going to hurt you trying to get out. That's pure limbic instinct. Run. And maybe the spider's this big. That is completely irrational. But now, if you go over here and you have a rattlesnake, I'll pick up a rattlesnake. Does that make sense?
Roger that, man.
So it's what that particular trauma, the triggers for that particular trauma. And trauma does affect the brain, the limbic system as well, because it's all about feelings. So a really good one. So this is another problem why addicts are sick a lot. So the sympathetic nervous system being on all the time, there's constantly having blood leave the gut and go to the skeletal muscle, because that's what happens when the sympathetic is engaged. We get anticoagulants. I'm sorry, that's wrong. It should be coagulants. I just realized I wrote that wrong. So blood coagulants enter the bloodstream. So what happens is you get a lot more blood clots in the bloodstream. Well, if you get enough of them, it can go to the head and cause a stroke, and it can go to the heart and cause a heart attack. Right. Now, the other thing that happens is the blood's left the gut. So it's out there in the skeletal muscle. Well, what's happening in here? I mean, there's a lot of important stuff in here, right? So it shuts down our immune system. We get poor digestion of food and sometimes irritation and infection of the digestive system, higher risk of diseases, more likely to have a heart attack, brain strokes, infections because the immune system's not working, and cancer and autoimmune diseases. Because what is cancer?
It's failure of the apoptotic pathway of some particular cell.
It's failure of the immune system to recognize an abnormal cell and remove it. And so it begins to multiply. And autoimmune diseases. In my family, there are six of us, 2 parents and 4 kids. 2 parents, both alcoholics. One of them didn't look like an alcoholic because she switched from alcohol to painkillers when I was in junior high school. So we all knew Daddy is an alcoholic. Mom, we don't know what's wrong with her. We just knew she was a little crazy. So when that's going on, what do you think happened to the rest of us? We are 6 and 6, all addicts. Now, I'm the only one in recovery. I'm 65. I have siblings younger than me and older than me, and they can't work. They've got autoimmune diseases, they've had all sorts of heart problems, brain problems, infections, cancer, because they didn't do the trauma resolution work that you need to do when you get sober from whatever your drug or a behavior of choice is. Now, when this is going on, while you're in the midst of your active addiction, you are not in the regrowth, in the repair mode of healthy tissue. Your immune system isn't working well, and part of what the immune system does is help to repair different tissue in different parts of the body, including the brain. So your brain cannot do its thing that we call neuroplasticity and regrow what we've lost, regrow those D2 receptors. Yes.
If you were in active addiction, active sex and love addiction, and you saw what you've been referring to as the hot guy, or whoever's attracted to you, and he were to produce a spider, what would you do?
Today, I'd run the other way
No, you're
from
in
both
active
of them.
addiction.
So, I've done some really strange things when there were spiders in the room. So, yeah, I wouldn't go towards him, absolutely, even in the height of my addiction. Now, I'd probably try to kill the spider and get him to never bring one back, maybe, and then chase after him. So, this part...
Did you say that you cannot, with the neuroplasticity of the brain, you cannot grow new brain cells at some point? Is that what you said?
So, if you're in this, in your active addiction, it prevents you, and that's one of the reasons that you lose your D2 receptors, because your brain is not repairing, because it can't. It's in the sympathetic. The opposite of that is the parasympathetic, and that's the rest and rejuvenate. The blood leaves the skeletal muscle, comes back to the gut to boost your immune system. It boosts digestion and all of those things. It basically restores homeostasis. Well, when you're in the sympathetic nervous system, you don't have any homeostasis. But homeostasis is when your entire body, including the brain, can regrow the tissue that has been impaired or lost or damaged. So, I want to talk about this a little bit, and then we're going to talk about recovery. So, we have seen something called acquired narcissism, and it's easier to see in a non-chemical addict. So what happens is we see, of course, their prefrontal cortex is offline. So if you think about the executive function that we do here, what are some of the things that we maybe decide from the prefrontal cortex? Do I want to break my marriage vows? No, I'm not going to do that. Overrides the limbic system. Am I going to go to a really dangerous part of town? No. So those are the things that we would do. We make good, healthy, informed, educated decisions with the prefrontal cortex. Well, if that's offline, I'm going to do what I need to do to get my fix, whatever that is. And I don't care if I am breaching every value I've ever had, and I don't feel bad about it. That's called acquired narcissism. So there's impaired thinking. My needs are more important than anybody else's. Survival, I got to get my shot of heroin, I got to get my fix, I got to see this guy over here, whatever it is that is my deal. So survival is about finding the next high. And that is impaired thinking. Because in the beginning, when we first got here on the planet, survival was about finding the next person to mate with so I could pass on my genes. Finding the farm, the trees, the fruit, the whatever that I need to feed me and my family. it had nothing to do with the next high. So very impaired thinking. The only thing that's important is the next high. Primitive parts of the brain are in charge now. So the limbic system is now in charge of the brain, and the prefrontal cortex is completely offline. So that's why we become self-absorbed and we isolate, because according to attachment theory, we need to be attached to something. Usually it's another person, or it may be a pet, or it may be a group. We don't care about that. The only thing, and a lot of times whatever it is that we're doing to get that high, we don't want other people to know about it. So we become very self-absorbed and isolated. And what happens when you're isolated to that chemical we talked about in the brain?
It becomes self-reinforced. There's no possibility. You get in an echo chamber, basically.
No oxytocin. We have to connect with other people to get oxytocin. And oxytocin helps us to feel okay with who I am. It's the thing that makes me feel comfortable in my own skin. So I don't care. I'm attached to whatever the behavior is, the alcohol, whatever it is. And so I really don't need anybody else. I don't have a desire to attach to anything. So we become very self-absorbed and isolated. But at the same time, we have all this self-hatred. And we feel awful. And we can't connect to other people because we are so attached to whatever our drug or behavior of choice is. So another part of addiction, it's an equal opportunity disease. It doesn't care who you are, how old you are, what color you are, whether you're a kid or an adult. And so I may start out with substances and then add behaviors, or start out with behaviors and add substances and add other behaviors. Now, the earlier the onset, because we talked about the formation of the brain, how our brain grows. So the younger I am, the more susceptible my brain is to a more severe addiction. And we've seen that. We say the kids get sicker quicker. So my brain's not even formed all the way until I'm 26. It's not completed. Now, I want to talk about this one, because this one is really showing up in our office. So last year, the first 6-year-old went into treatment for pornography addiction. The younger they are when they start having, and so if you think about pornography, there used to be the magazines and you go, oh gosh, and you could move that away. But if you're hearing it, you're seeing it, and for a child, it's compelling. It's both disgusting and they want to reject it, but they also want to keep one eye open and look at the screen. They are compelled because they don't know anything about this. It's novel, and as humans, we seek out novelty. And so this new thing that we've never seen before becomes extraordinarily compelling, and this kid is going to get addicted fast, very fast. So it's what we call a super stimulus. So in their little brain, they're getting a flood of dopamine. And so they are both disgusted and compelled to come back to whatever it was that they saw, because they get a hit of dopamine. And they may never have experienced that kind of high and excitement in their life. So they are hooked. It's like crack cocaine. The first time they see it, they're addicted. So important for us to keep our children safe. Now here's where Helen Fisher comes in. Can love or romance be an addiction? Well, I've already shared my romance addiction with you guys. So this is an fMRI that Helen Fisher did. She had several subjects, a bunch of subjects. And she had a control group, people who were not currently in love, and then another group where they said, I'm very much in love with whoever I'm with. So she put them in, and she showed them a neutral picture, like a picture of a blank wall or whatever. Did the MRI. Then she showed them a picture of their loved one. Did the MRI. Guess what that is? Guess what that is? BTA, nucleus accumbens. Yeah. That's why we do stupid things when we're in romance and in love.
I was going to ask, this is people who are newly in a romance.
They're still in the romantic phase of the relationship. Yeah.
Or 6 to 18 months or so.
Yeah, eventually this will go away. unless the love that they're feeling for the other person is not returned. And so then they usually try to recreate that sense or that feeling, and they may go into severe withdrawal, but they'll still try to convince themselves that there's some hope that this relationship's going to work. And so this keeps acting out inside the brain without them even seeing the other person.
So just to make sure I'm hearing this right, you're saying that in a case of unreciprocated affection, love, as it were, it
Yeah.
can actually lead to a prolonging
Yeah.
of the, I guess, the unrequited party?
Yeah, trying to get this back.
Is that the, really? That's wild. Okay. Yeah, you can get more addicted to the person that's treating
Exactly.
you like garbage.
That's right.
That's what I'm hearing.
That's what you're saying, and that's what I'm saying. You heard it, and I said it. All right. So how can the brain heal from the addiction and this acquired narcissism that we have? How many of you can relate to that acquired narcissism?
Well, I meant to ask you about that.
Yeah.
So one of the things you're talking about how the sort of the addictive pathway works and everything like that. Do you think that addicts are purely made, not born?
Purely made, not born?
Made,
Okay.
not born.
So
See what I'm saying?
So in addition to everything that I'm telling you tonight, we know there's a genetic component. My family is a perfect 6 out of 6, a perfect example of that. But there was also a hell of a lot of trauma for both parents that they passed on to us, and then we got traumatized and carried a lot of their feelings. So and it was like this: my father, his father, his grandfather, and all the males this way and that way. I mean, it was like 100% alcoholics in that family. On the other side, I don't have as much information because my father got sober, but my mother didn't. And so she thought everybody was just fine. There's no telling. Well, and her father died when she was 3 of, quote, stomach cancer. I bet it wasn't stomach cancer. Yes.
Could you repeat the distinction between, when it comes to acquired narcissism? Like, on the one hand, I could see it being a symptom of somebody who's addicted, but you also, I thought you said that sometimes it's independent of somebody who's addicted to a behavior or a substance.
Yeah,
Is
you
that right?
did demarcate it, yeah.
So I'm saying that somebody that comes in and, you know, we check all the boxes for narcissism, we don't say you have narcissistic personality disorder until they've been sober a while, because they may not be. Because the brain starts to create what we call acquired narcissism. That's all reversible, just like addiction is.
Okay, so to just make sure I've got this clear, because it's a good.
Yeah.
So the set of all people who have acquired narcissism, are they a subset of all people who are addicts?
So,
see what I'm saying?
right.
The set of all people who have.
So if they were very codependent and loved everybody and tried to do things for everybody, they're probably not going to show up with the acquired narcissism. But somebody who maybe has a little self-centeredness and they become active in their addiction, they're going to show up with some pretty severe symptoms.
And the reason that's demarcated and tacked on as an adder is that there are some people that have narcissism disorder.
Right.
And there are some people who have addicts, and this is a spin-off of that. is what
Yeah.
you're saying.
And so
This is that
when we see
egomaniac with an inferiority complex.
right, and so we see people come in and they're like, oh my God, they're so narcissistic, and then 3 months later they're just the sweetest, most empathetic person on the planet, and we're like, what happened? A gigantic shift in how they see their fellows. And you know, one of the things that AA does is it helps us focus on being of service, being kind to others, having empathy for other people. And so, you know, I know that their brain changes very quickly, but some of it is about how we educate. And AA does a great job of that. And we use a lot of those principles here to help people come out of that acquired narcissism and begin to have empathy and caring for other people. But when we're in the midst of our addiction, we don't care who gets hurt when we're out there acting out. So plasticity is the brain's ability to change in response to the environment. So I love Philip Flores. He had some really good slides the last time he came into town. He wrote a book called Addiction as an Attachment Disorder. And one of the things that he talks about is when you put an addict in individual therapy with a therapist, their progress can be 0 to a tiny bit. But when you put that addict in a group of other addicts, they begin to feel empathy for the other addicts. They begin to respect the other people in the group. They begin to develop oxytocin for the other people in the group. So it is the environment that they're in. It's not the wonderful, great work that I do to help them get sober. It's the environment where they are with other people that they can relate to, and their brain begins to respond to the connections with other people, and their brain changes a lot. We're hardwired as a species to adapt to our environment. That's why we can live in Antarctica, on the Arctic, high on the mountains, down in the valleys, in the hottest places in the world, and in the coldest places in the world, because our brain, and not only does the brain change, but the rest of the body changes in response. So when winter starts coming, do you notice that it feels really cold at first, and then after a while it's like, well, it doesn't feel that cold anymore. Our body, related to the plasticity of the brain, is adapting in response to our environment. So when you put an addict in a place with a bunch of recovering people, they want to fit in. It is natural for us to be and live in tribes and communities. So they begin to adapt to and adopt the thinking, the new thinking in the group, and they want to please the other people in the group. It helps the addict stay sober. It's amazing how that happens. That's why AA works so well. So the lower parts of the brain, the reptilian brain, is much less flexible. The limbic system is a little less flexible, but the part of the brain that actually is the most plastic in this system is that prefrontal cortex. So it changes pretty rapidly. However, this is the thing that a lot of people don't understand. Why do we, for example, if you're a sex addict, are you going to stop having sex for the rest of your life? I don't think so. But there's a period of abstinence where the compulsive part of the brain, that neural pathway, dies off, and there is a different pathway that begins to grow in there that is a healthy sexuality. I've had guys tell me, I don't think I can ever do plain vanilla sex ever again. It's just not going to do anything for me. 6-8 months later, they're beginning their sexual reintegration with their partner, and they're like, oh my God, this is wonderful. I never felt like this before. Well, yeah, I know it didn't feel like that before. Had the same experience myself. So the limbic system takes a little longer to heal. So what's up here? What kind of tissue is in the brain? It's nerve tissue, nerve cells. So if you get a cut inside your mouth, how long does it take to heal?
A couple days.
At most. Sometimes overnight. What if it's on the skin? 3-4 days, maybe a week. What about if it is muscle? You get a bruised muscle.
Forever.
2, maybe 3 weeks, sometimes longer. What if it's a bone? How long is that going to take?
Yeah.
Yeah, at least for 8 weeks. Well, nerve tissue is the longest healing tissue in the body. So we know it takes a minimum of 90 days to grow that new neural pathway. And so there has to be abstinence around sexuality and romance. I can look at some guy, oh man, that is, get high. So those are things I can't ever do because it's going to fire up that old neural pathway that has been dormant for 28 years now. I don't want to fire up that. That person is not allowed in my life anymore. She is one crazy woman. So this part's going to heal before actually the limbic system begins to heal because this is more plastic. Now, cortex and limbic system, as you're growing up, its plasticity lessens as we get older, but some degree of plasticity remains until we are 6 feet under. We can still adapt and our brain can change in a new environment when we're in our 90s. It may be a little slower, but we do have plasticity. So here's the thing. The plasticity in the brain, that repair occurs only once the insults to the limbic system cease. Now, we know trauma affects that part of the brain. And so sometimes I'll have someone who is, let's say they had a lot of family of origin injury, and maybe they're living with their brother. And mom comes over a lot or dad comes over a lot. They are never going to heal their limbic system from that trauma as long as they are bombarded or receiving insults to the limbic system. The same thing is true for addiction. You can't just decide, well, I'll do a little bit of marijuana. I'll just have one drink. I'll just do blah, blah, blah. The plasticity is in stalemate until those insults to the limbic system stop. Yes?
Do you have any thoughts on this aspect of it as it relates to MAT recovery?
So when I'm going to be very curious and do my science observation piece around watching that when it happens. Because I'm very curious about, can that happen for a person who's still putting mood-altering chemicals in their limbic system? And it may be that there are some like chemicals that may not insult the brain, but you know, that's why they're doing studies on this right now. So we can see what's it going to look like, how's that going to work. So, and again, the insults to the limbic system with regard to addiction are repetitive high volume dopamine releases. Those are the insults that occur to the limbic system that prevent it from healing. That has to stop. And just like trauma has to stop before we can repair our limbic system. So abstinence is the only way that the brain can heal that we know of. We'll see how that works in some other areas. So here are the references that I used tonight. There's a great article on exactly what happens in the womb, and then year at birth, and then year 3, 4, and 5 with kids. And it also talks about what does it do to the brain development when the kids aren't in a safe environment, not a healthy environment. And this guy's where I got the information about the evolution of the neocortex. And this guy has all those pictures of the brain. And then this is Nora and then Helen Fisher. So those were all the things I pulled together to do this with. And there's some really good websites. I gave you a couple at the beginning, and there's another one that I really encourage you to watch, and it really helps look at the limbic system in the toddler. And the name of the video is, and it's not on your paper, and I really encourage you to look at it. It is called Still Face. And some of you have probably seen the video, Still Face. Still Face is an experiment with an 18-month-old, and seeing how mom and baby have what we call limbic resonance. Now, you have a handout. Can I borrow your handout? Just this one, yeah. This is a really good handout that I just came across today. So, when the brain is developing, this is a whole other lecture, but I just want to mention this because it's so important. So, when the brain is developing, a child needs to have emotional connection, or what we call limbic resonance. In other words, I feel for you a similar way that you feel for me. And I know you like me, and I know you don't like me. So I am in tune with you, and maybe you're putting off some hostile vibes, and I don't want to get anywhere close to you. But mommies and babies especially have the kids whose brains are developing well and in a healthy way have limbic resonance. And so what it says about it is the capacity for sharing deep emotional states arise from the limbic system in the brain, which we know. And these include the dopamine circuit promoted feelings of empathy and harmony, or empathic harmony. There are other chemicals that actually are produced when you're feeling fear, anxiety, or anger. So there's a great book called A General Theory of Love, and it's a tiny little book. And I encourage you to read it. It's very good. It talks a lot about limbic resonance.
What's the name again?
The General Theory of Love. The General Theory of Love. It's in that second bullet point. And so, in other words, it refers to the capacity for empathy and nonverbal connection with your partner, with your children, with your siblings, with your own parents, or not. Some have difficulty with that. Our nervous systems are not self-contained. My nervous system is going to connect to yours, and to yours, and to yours. And some people just don't know how to do that. They can't do that. And those people who can't have limbic resonance with their clients are going to have a really hard time creating any change, because we know the number one most effective part of therapy is the therapist being able to have limbic resonance with the client. And the limbic resonance that occurs when people are in a group to heal from trauma or anxiety or addiction is a huge part of what actually causes the healing. So if the therapist can get out of the way and let the group have limbic resonance between them, that group therapy is going to go a lot better. If you're in a room full of crazy people and you know you're sane, you're going to feel crazy after a while because of the limbic resonance. If you're in a room full of very positive people, you can't stay in that room very long without feeling positive and thinking in a positive way. The same is true for being in a room full of negative people. So when we say hang out with the winners and choose your group well, that's what we're talking about. It doesn't matter that you aren't even speaking to the other person. We still have limbic resonance with our neighbors, with other people, or not. And we are going to know pretty quick if the other person is capable of returning the same limbic resonance. But in the still face video, mommy and baby have really good limbic resonance. And when you watch it, you'll see, because she takes a time out from limbic resonance with the child, and you get to see what happens to that child. This kid's only 18 months old. No speech, cannot talk. But he knows when mom's in limbic resonance with her or him. He or she knows. So next month's topic is going to be toxic shame, and we're particularly talking about what causes it, how it affects your recovery. If you've got toxic shame on board, it's really hard to move forward in any kind of recovery behaviors because the toxic shame stops you. You cannot move forward. And we'll talk a little bit of about how we heal from toxic shame. Thank you.